The principle you recall about the ground wire being the longest within an electrical box is indeed correct. The purpose of maintaining the ground wire as the longest is directly related to electrical safety during device servicing and removal. When working with electrical devices, the sequence of wire disconnection is crucial. The ground wire should always be the last wire to be disconnected. This ensures that the device remains grounded for as long as possible during the disconnection process, providing a continuous path to ground in case of an accidental short circuit. Your observation regarding the stranded ground wire on the fixture box being only half as long as the hot and neutral wires raises a valid concern. While it may not automatically constitute a code violation, it's important to address the potential risks. Several methods can be employed to mitigate this situation. Firstly, the use of a wire nut to connect the ground wire from the fixture box to the hot and neutral wires is a possible solution. This establishes a secure electrical connection which ensures that the ground wire remains connected and provides continuity to ground until the other wires are disconnected. Secondly, another effective approach is the utilization of a ground pigtail. A ground pigtail is a short length of wire added to the existing ground wire in the fixture box. One end of the pigtail is connected to the ground wire within the fixture box, while the other end is connected to the ground wire of the electrical device. This extended ground wire ensures a reliable ground connection to the device, even if the original ground wire in the fixture box is shorter than ideal. Ensuring the ground wire is of the correct gauge is crucial for electrical safety. The ground wire should be the same gauge, meaning the same diameter and current carrying capacity as the hot and neutral wires in the circuit. The reason for this is that in the event of a fault, the ground wire is expected to safely carry the fault current back to the source. If the ground wire is undersized, it may not be able to handle the fault current, potentially leading to overheating and fire. When assessing the gauge, refer to the ampacity tables in the National Electrical Code, commonly referred to as the NEC. NEC Table 310.15 or its equivalent is used to determine the appropriate wire gauge for a given amperage. For example, if the circuit is protected by a 20 amp breaker, the hot, neutral, and ground wires should be at least 12 gauge copper wire, according to NEC Table 310.15. Always consult the latest edition of the NEC and any applicable local codes for specific requirements in your area. Furthermore, the connections within the electrical box must be made correctly to ensure safety and compliance. All wire connections, including those made with wire nuts or other approved connectors, should be tight and secure. Loose connections can cause arcing, overheating, and potentially lead to electrical fires. When making wire connections, ensure that the wires are properly stripped and twisted together before applying the wire nut. The wire nut should be tightened firmly to ensure a secure connection. It is also important to verify that no bare wire is exposed outside of the wire nut, as this can create a shock hazard. In addition to ensuring that the ground wire is of the correct gauge and that the connections are made properly, it is also important to ensure that the electrical box itself is properly grounded. The electrical box should be grounded by connecting it to the grounding system of the building. This can be done by connecting a ground wire from the box to a grounding screw or clip located inside the box, which is then connected to the building's grounding electrode system. The grounding electrode system typically consists of a ground rod or other approved grounding electrode that is connected to the earth. The purpose of grounding the electrical box is to provide a path for fault current to flow back to the source in the event of a short circuit. This helps to protect people from electric shock and to prevent damage to electrical equipment. When grounding the electrical box, it is important to use the proper grounding hardware and to follow the instructions provided by the manufacturer. The grounding hardware should be listed by a recognized testing laboratory, such as Underwriters Laboratories, commonly referred to as UL, and should be suitable for the application. When making the grounding connection, ensure that the wire is clean and free of corrosion. The grounding connection should be tight and secure to ensure a reliable electrical connection. Following these guidelines will help ensure that your electrical system is safe and code compliant. Always remember to turn off the power at the circuit breaker before working on any electrical circuit. If you are not comfortable working with electricity, consult a qualified electrician. Additional considerations are needed when dealing with old work recess cans. These fixtures are typically installed in existing ceilings, which can present challenges in terms of access and wiring. When installing old work recess cans, it is important to carefully assess the existing wiring to ensure that it is in good condition and that it is properly sized for the new fixture. If the existing wiring is damaged or undersized, it should be replaced before installing the new fixture. It is also important to ensure that the electrical box is properly supported and that it is securely attached to the ceiling structure. The electrical box should be rated for the weight of the fixture and should be installed according to the manufacturer's instructions. When making the electrical connections, be sure to follow the same guidelines as for any other electrical circuit. Use the correct gauge wire, make tight and secure connections, and ensure that the ground wire is properly connected. If you are unsure about any aspect of the installation, consult a qualified electrician. In summary, prioritizing electrical safety during installations is paramount. The length and gauge of the ground wire in electrical boxes are critical factors. When the ground wire is shorter than the hot and neutral wires, it's important to take steps to mitigate the potential hazard, such as using wire nuts for ground pigtails. The ground wire should be the same gauge as the hot and neutral wires to ensure it can safely carry fault current. The electrical boxes must be properly grounded and connections should be tight and secure. When working with old work recess cans, it is important to carefully assess the existing wiring and ensure that it is in good condition. Adhering to electrical codes and best practices ensures a safe and compliant installation. If you are not comfortable working with electricity, consult a qualified electrician. Remember, the primary goal is to create a safe electrical environment. That includes proper wiring, grounding and connections. In addition to the factors already discussed, it's also important to consider the type of wiring used in the electrical circuit. The type of wiring used can affect the ampacity of the circuit and the safety of the installation. Common types of wiring include non-metallic sheath cable, commonly known as NM cable, and armored cable, commonly known as AC cable. NM cable is typically used in residential wiring, while AC cable is often used in commercial and industrial wiring. Each type of wiring has its own advantages and disadvantages. NM cable is relatively inexpensive and easy to install, but it is not as durable as AC cable. AC cable is more durable and provides better protection against physical damage, but it is more expensive and can be more difficult to install. When selecting the type of wiring to use, it is important to consider the specific application and the environmental conditions. For example, if the wiring will be exposed to moisture or corrosive substances, it is important to use a type of wiring that is suitable for those conditions. It is also important to ensure that the wiring is properly supported and protected from physical damage. This can be done by using cable clamps, staples, or other approved methods. The wiring should be installed in a neat and workmanlike manner, and it should be protected from sharp edges or other objects that could damage the insulation. When making connections to the wiring, it is important to use the proper connectors and to follow the manufacturer's instructions. The connectors should be listed by a recognized testing laboratory, such as UL, and should be suitable for the type of wiring being used. The connections should be tight and secure to ensure a reliable electrical connection. In addition to the physical aspects of the electrical installation, it is also important to consider the electrical load that will be placed on the circuit. The electrical load is the amount of current that will be drawn by the appliances and equipment connected to the circuit. It is important to ensure that the circuit is properly sized to handle the electrical load. This can be done by calculating the total load in the circuit and then selecting a circuit breaker or fuse that is rated for that load. The circuit breaker or fuse should be sized to protect the wiring from overheating or damage. If the circuit breaker or fuse is too small, it will trip or blow frequently, which can be annoying and can also damage the appliances and equipment connected to the circuit. If the circuit breaker or fuse is too large, it will not provide adequate protection against overloads or short circuits, which can lead to fires. When calculating the electrical load on a circuit, it is important to consider all of the appliances and equipment that will be connected to the circuit. This includes lights, receptacles, appliances, and any other electrical devices. The load should be calculated in amps, and the total load should not exceed the rating of the circuit breaker or fuse. In addition to calculating the total load on a circuit, it is also important to consider the voltage drop on the circuit. Voltage drop is the decrease in voltage that occurs as electricity flows through the wiring. Voltage drop can cause appliances and equipment to operate less efficiently, and it can also damage the wiring. The amount of voltage drop on a circuit depends on the length of the wiring, the gauge of the wiring, and the amount of current flowing through the wiring. To minimize voltage drop, it is important to use the correct gauge wire for the circuit. The larger the gauge of the wire, the less voltage drop will occur. It is also important to keep the length of the wiring as short as possible. In addition to the technical aspects of electrical installations, it is also important to be aware of the legal and regulatory requirements. Electrical installations are typically governed by national and local electrical codes. These codes specify the minimum requirements for electrical installations and are designed to protect people and property from electrical hazards. It is important to be familiar with the electrical codes that apply to your area and to follow them carefully when installing electrical wiring. Electrical codes are constantly evolving, so it is important to stay up to date on the latest changes. You can obtain information about electrical codes from your local building department or from a qualified electrician. In addition to electrical codes, there may also be other regulations that apply to electrical installations. For example, some areas may require permits for electrical work, and some areas may require inspections of electrical installations. It is important to check with your local authorities to determine what regulations apply to your area. When hiring an electrician, it is important to choose a qualified and experienced electrician. A qualified electrician will have the knowledge and skills to safely and properly install electrical wiring. A qualified electrician will also be familiar with the electrical codes and regulations that apply to your area. To find a qualified electrician, you can ask for referrals from friends, family, or neighbors. You can also check with your local Better Business Bureau or with professional organizations such as the Independent Electrical Contractors, commonly referred to as IEC, or the National Electrical Contractors Association, commonly referred to as NECA. When interviewing electricians, be sure to ask about their qualifications, experience, and insurance coverage. You should also ask for references from previous customers. Before hiring an electrician, be sure to get a written estimate of the cost of the work. The estimate should include a detailed description of the work to be performed, the materials to be used, and the labor costs. Be sure to compare estimates from several different electricians before making a decision. Once you have hired an electrician, be sure to monitor the work closely. If you have any questions or concerns, be sure to discuss them with the electrician. Do not hesitate to ask the electrician to correct any mistakes or to make changes to the work. It is your responsibility to ensure that the electrical installation is done safely and properly. By following these guidelines, you can help to ensure that your electrical installation is safe, code compliant, and reliable. If you are not comfortable working with electricity, it is always best to consult a qualified electrician. Electricity can be dangerous, and it is important to take the necessary precautions to protect yourself and your property.